Okay, now we consider to study Chapter 1, Matrices and Systems of Equations. In this lecture, we will learn about matrix algebra. So first part, we will learn about notations, matrix notation, vectors, and equality. We use capital letters A, B, C, etc. to denote matrices. If A is an n by n matrix, then we write A as this type. So the first row is A11, A12 till A1n. The second row is A21, A22 till A2n, and the mth row is AM1, AM2 till AMN. Here, Aij is the entry of the matrix A in the ith row and the jth column. So Aij usually are scalars, either real or complex numbers. And we can write A as a parenthesis small a subscript ij. So Aij is a representative entry of the matrix A. Similarly, we can write B as a smaller b subscript ij, and C can be written as a parenthesis with its representative entry C subscript ij. And as a special type of matrix, we consider vector. So vector is important because it can represent the solution of the linear system. An n tuple of real numbers can represent solutions to linear systems, and we call it is a vector if the matrix has only one row or one column. We say this is a row vector if it's a 1 by n matrix. And we say it is a column vector if it's an n by 1 matrix. And we denote by Rn the Euclidean n space. Euclidean n space is a set of all n-dimensional vectors. If you consider a row vector, you can write as x bar, which composed by x1, x2 till xn. And if you consider column vector, you can write x as a column vector, an n by 1 matrix, x1, x2 till xn. So this is the notation for vector. And in matrix, you can see easily that it is composed by row vectors. In fact, there are m row vectors, which, for example, the ith row, I just represent here, the ith row by the red rectangle, okay? And also you can consider the matrix A be composed by column vectors. So there are altogether n column vectors in this matrix, n by n matrix. And here, I represent it by the green vertical line. This is the jth column of the matrix A. The ith row vector of A, you can write as AI with an arrow above it. So this is the ith row of A. And you can also write as A parenthesis I and the semicolon here. So with entry-wise, you can write AI1, AI2 till AIN. This is the ith row of A. And you can write arbitrary row of A in this notation. For example, the first row, the second row, and the mth row. And you can also, using the column vector of A, the jth column for A. So Aj here means a jth column for A. So you can also write as A semicolon J. Its entry-wise is A1J, A2J till AMJ. For J varies from 1 to till n. So this matrix A, you can write as it composed by row vectors. The first row of A, the second row of A till the mth row of A here. And you can also write A as column vector. It is composed by the first column for A, the second column for A till the nth column for A. And now we consider the equality between two matrices. So for two matrices to be equal, we need two conditions. First, they must have the same dimension. And secondly, their corresponding entries must agree. So the formal definition is like this. Two n by n matrices A and B are said to be equal if Aij equals Bij for each I and j. So we say this simple example. We have A, a 2 by 3 matrix given like here, and we have B matrix, also a 2 by 3 matrix, right? And we know that A equals B. Then please find out X, Y, and Z. So it is easy to say that X should be 2, right? And Y should be 3, right? And Z should be 2. So each entries correspondingly, they are equal. So X equals 2, Y equals 3, and Z equals 2.